Okay, so let's just work on the final. Unless you guys have other things you wanted to ask me, like general questions about stuff that you've learned. Okay. In the space below, write what is printed when the following program is executed. So we have an add function which returns the sum of two numbers and also prints that it's doing so. We have a function that doubles something that prints that it's doing so. And then we have this if statement. Okay, so if we double 10 and add 20, if that is greater than 0, which it is, and add minus 25 to the double of 5, which is minus 25 plus 10, then, okay, so we're definitely not going to print yay, right? Because this will fail, for sure, and that's an and. So both of these things have to be true in order for this to print. So this is, in fact, the thing that's going to trigger. So we're going to get oops, and then it's going to print add double 3 and 0. Okay, so you have to be very careful. I'm going to pull up, yeah.
Is the doubling 10 not going to print when it's evaluated?
Yeah, everything will print. So we're going to have to be careful. That's why I want to open this up. So let's try and be careful as we do this. What? What's that? That's not what we're doing. Yeah, I pulled it to the wrong one. Go. I need more space. Come on. Yeah. All right, good enough. Okay, perfect. Right. Okay, so I think we're just going to go left to right here. So it's going to do this first. So first it's going to print adding what? Geez, how is this going to work? Is this going to do add or double first?
I think that's going to do double first.
Yeah, we'll do double first. Okay, so first it's going to double 10. Then it's going to doubling 10. And then we're going to adding 20 and 10. 2020. Oh, yeah. 2020. And then we do double 5. And then we do adding, doubling 5, adding minus 25 and 10. And then we doubling 3. And then adding 6 and 0. And then, oops. You sure? That's the thing that's what I'm uncertain about. Okay, hold on. Let's deal with the complaints as they go. So someone had a complaint about a comma? Oh, right. Oops. Right. Oops, comma 6. Really?
Yeah.
I didn't know that. So if I do this and then this, just going to concatenate it with a space. Can I do multiple ones of these? Okay. Wait, so are those spaces meaningful?
No.
Okay. So it's not really concatenation, because concatenation wouldn't add the space. This is like something weird.
Print is a variant.
What is the type of this thing?
Print is variadic, so you can have as many arguments as you want.
Right, so I can't assign something to the what print is printing.
It will return none.
It's none, yeah, okay. Okay. So it's not concatenation. It looks kind of like concatenation. Well, but again, this is what I've been yelling at you guys all year, right? Like the print isn't a function. Print is a special thing that is for humans. It's the computer-human API, essentially. Yeah, I'm going to have a whole lecture if I ever teach this class again about printing and how not to use it. Okay, so what we need to know is what will print first, the oops or the doubling. Okay, well, I'm just going to write a function foo, which takes x and prints, I don't know, doubling. Oops. Doubling x, return 2 times x. I'm going to print, oops, I did it again. Foo 1. Okay, so I think oops is going to print before it tries to evaluate foo of 1. No. I changed my mind. I think it's going to print the doubling and then print oops. Well, let's just see. Yeah, doubling first. Yeah. Because I guess it has to it has to evaluate everything it's going to print first and then send it out. Right? So that's why I think it has to go into the, because I'm thinking what would happen if I had done something like this. You know how we have this formatter? I can just, I didn't really show you too much about the formatter. It just allows you to put like a number in a print, right? So this way it would have to evaluate foo1 first. Okay. Complete the example function calls by adding the expected return values. Oh, I like questions like this. Okay, maybe not. I like questions where they ask you to predict the input for the output, because it forces you to understand how the code works rather than just trace through. But anyways, so let's try and figure out what this code is doing. Let's try and figure out what this code does, and then we'll try to write the output for the docstring examples, right? So please don't, like, you should only start tracing the code as a last resort. Right? It's going to take a really long time, and you're probably going to make mistakes. It's better just to sort of look at the code and try and figure out at a higher level what it's doing. So this is going to, okay, it seems to be accumulating a string. It's going to iterate through the length of s with a counter I. And if the index is not divisible by 3, then we're going to append to the answer. Okay, so I think that this code is removing all characters that are at a position 0 mod 3, or that is, do you know what I mean when I say 0 mod 3? Yeah, you just remove every third position starting from 0, right? So the 0 position goes 3, 6, 9, right? Okay, so what's every third position in hello world? So that's, I take away the h, okay, 1, 2, sorry, yeah, 1, 2, 3. No. 1, 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, Jesus. Okay, hold on. 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Hello, world. Okay, so I remove H, I remove L, I remove that L as well. So this should be, yeah. No, there's a not equal there. Right? So you're removing only the ones that are at the 0. Lots of mumbling. What did I do wrong? Yeah. Didn't I remove the W? I'm going to try this again. H goes, L goes, oh yeah, W goes, and L goes. Okay. But we got to be careful, right? Because you have to keep the space, right? Remember, space is not special. Space is a character. It just doesn't happen to display anything, but it's a character nonetheless, right? So please don't eliminate spaces because you think they're special. They're not special. Okay, so let's do summer now. Summer. 0, 1, 2, 3, 4, 5. So I guess we got to remove 0. This. Oomer. I know an oomer. Okay, so that one's good? Yeah. So, but we're not removing letters, but that's the effect of the algorithm. Yeah, but what letters? Okay, so I'm saying we're removing the third letters. That's equivalent to saying we're accumulating the positions at the 1 position and 2 position. I'm building a new word and leaving out every third position, which is equivalent to what you're saying. Right? Well, how else can we remove something if not by building it and leaving the things out that we want to remove? We're never able to remove stuff from a string. Strings are immutable. So even removing characters from a string will require that we build up, right? We can never remove something from a string. Huh? Yeah, but even those string methods are returning new strings, right? So just because you're asking someone else to do it, right, doesn't mean they somehow now have special power of like mutating strings. Nothing in Python can mutate a string, right? Well, should I code this in just to prove it to you guys that, like, do you not believe like do you believe that this is the output? No, that's a not equal. Are you missing the not equal? Okay. Yeah, it's not equal. Okay. We all on the same page now? Great. Valid passwords. Didn't we do this one? Like last time we were preparing? No? Well, because we did some, when we're preparing for the midterm, we went over some old exams. I feel like we did this one. Well, anyways, let's do it anyways. Return true if and only if the given string is a valid password. A valid password must be exactly 8 characters long. Okay. I'll just code it up here. Valid, okay, foo. Whoops. Whatever. Valid password S. Probably should save this as something. Today. Okay, so a valid password must be exactly 8 characters long. Okay, if length of S not equal to 8, return false. And if I make it to the end of all these tests, I'm going to return true. Exactly 8 characters long contain at least one uppercase character. Uppercase character. So how can I test if a character is upper? Is there an is upper method? Is it just is upper? No, dot upper converts it to an upper. I could just use is upper, right? I like your enthusiasm. That's good thinking, right? Okay, so how do I do this? At least one lowercase character. All right. Shh. How do we check for one lowercase character? Okay, we could do that too, right? A, B, C, D. Oh, hold on. No, it's fine. It's fine. That's not bad reasoning. Okay, so here are the lowers. But like, how does that help now? Like, I still want to know how I'm going to see if this string contains a lowercase letter.
We can say or lowercase c. Like we can say or lowercase a less than or equal to x less than or equal to or x less than or equal to
Yeah, but like, by which mechanism can I find, like, I need to do a loop, surely, right? So for, why do they make it S? For x and S, if S is, do I need one upper and one lower? If S is upper, upper equals true. If S, wait, if it isn't upper, does it make it lower? No. Because I guess there are like punctuation, which are neither a lower or upper. Okay, if this is lower, sorry. I can't see anything. All right, I got to take this out. I don't have enough room. Okay, for x and x, if s is upper, upper equals true. If this is true, lower equals true. I'm going to say upper, lower, false, false. Where did it go? One upper, one lower, one digit, and one of the following symbols. Okay. Is there an is digit? Maybe is numer? Okay. Is digit, then digit equals true. So I'll put this. And one more special character. Special. If S is in a special character, what were they? Okay, guys, are there some questions? You don't have to be in lecture, right? So, can I help? Or is there a problem?
What's the difference between the is digit built-in and the is numeric?
Well, 1.3 isn't a digit, is it?
No,
But it is numeric, right?
it is still very small.
Is it numeric? Let's check. Good question. What's the other one? Is digit? Well, hold on. Will this return true? Yeah, because it's looking at the individual. Okay, is digit, is digit. What's the other one that we wanted? Is numeric. Returns true if all characters in the string are numeric. False otherwise. Well, then what's the difference, right? This method returns true if all characters in the string are digits. And there is at least one character? False otherwise? Is that the difference? One of them will return true on empty? Nope. All right. What is difference between is numeric and is digit Python, right? Oh, and is decimal. It's mostly about Unicode classification. Oh, okay, so like there's a 1/2 symbol, I guess, which is numeric, but not a decimal and not a digit. So the footnote like symbol is a numeric, but not a decimal, but it is a digit. Okay, so remember, we have like the whole Unicode database. Like I wonder, does anyone know, I'm really curious if the emoji for 100 with those 3 lines under it is considered a digit. Pretty sure I can just paste that, yeah. Oh, I need quotes, yeah, you're right. It's hilarious to me, I don't know why, right? Okay, so hold on. So we have X. Is this a digit? It's not a digit, but is it numeric? No. What's the other one? Oh, but it's not a decimal. Okay.
Can you cast it to an int?
I could cast it to an int. No, I can't. Huh?
I was gonna ask what's the table back.
Yeah, it's a string. I think we can get the Unicode for this. How? Remember we're doing ORD. Yeah, ORD. There you go. ORD 1, 2. 128 175. Right. So you guys can just tweet like Unicode numbers at each other, right? Oh, that would have been a fun object to make. Just like replace all numbers with like emoji and then like contrive like emoji arithmetic. I'm going to do that next year. It's not a bad idea. Okay, and anyways, let's go back to this, and let's agree that if you have questions, you should ask the prof instead of talking amongst one another. Hash, okay. Hash in this guy. And then special equals true. And then at the end, I just want to return. So all of these things have to be true in the end, right? So it has to be the case that upper and lower and digit and spec. Right? All right, x. Okay, well that will work. I'm not even going to test it. Huh? Yep, that shouldn't be there. Okay. So that would have got you 5 marks. Out of 10 million. Question 4, do stuff. So what does do stuff do? It takes in 2 lists, pointers. To the first list, it appends D. To the second list, it appends D differently. And then it just converts S to upper. Okay. So if X is this and X, okay, so X is ABC, X1 is X, X2 is the slice of X. Now, I always forget this. When we slice, is that creating a new object? No, I don't think that'd be very efficient. Well, you guys tell me what this outputs. Okay, so X is A, B, and C. X1 is X. X2 is the whole slice of X. And then we pop something from X1. We learned the other week that we can pop any position, right? So it's going to pop the front of the list. And then S is equal to X1 at 0. Right. Value do stuff. Okay, so if we send all of this into here, what happens? Well, let's start with the easy stuff first. So do stuff returns nothing, right? There's no return. Okay, so value, which is being assigned the output of do stuff, will be none. Right? That's the easy one. S. So S is just a character. So it doesn't change if it gets sent into a function. Right? You're not getting a pointer, that's just a copy. So S should be X1 at 0, which is A. So S will be A, value will be none, so those are the easy ones. So what will happen to X and X1 and X2? Oh, we popped A. Okay, sorry, yeah, it will be B. It will be B. So what will... All right, let's figure out what X will be. So we have X, and we've popped the front, but we've also added D to the back. So is this going to be B, C, D? Are they all going to be B, C, D? Yeah. No, I think when you give it an integer, it will pop that position. Yeah. Otherwise, it pops the end. Okay, I think maybe we should type this stuff into the compiler. Type this stuff, do stuff into the compiler. Okay, let me get this here. Do stuff, L1, L2, S, 2, 3, 4. L1 is L1 plus D. L2 dot append D. S is S dot upper. Okay, so X is A, B, C. X1 is X. X2 is the whole slice. So that should be the whole thing. Okay, so X1 dot pop of 0. This should return A and remove something from X, right? Okay. And let's see what happens. So X is this. X1 should be the same. And X2 should be the same. No. Okay, that's what I was afraid of. Okay, so please remember this. When you list slice, it's going to create something new. Every time you slice, it makes a copy, it would seem. Right? So that's the important thing to take from this. And then we're going to say S is equal to X1 at 0. So B, that was correct. And now value gets do stuff of x1, x2, and s. Okay, so what is x here? What's x? B, C, D. Oh, no, B, C? What about x1?
Or L1 isn't equal to X1. It's a local variable.
Oh, good job. Yeah, so this is, these are both, okay, so L1 is local to this because we said L1 is equal, right? So that's going to make a local copy of the list inside. I'm not sure the same is true of L2 though. Oh, I don't have L2. What was it? X2. Yeah, X2. Yeah. So that's the difference, right? This L1 created a local copy and instantiated L1 as a local variable, right? So the stuff that we're doing to L1 is happening locally, whereas the stuff we're doing to L2 is happening globally. And of course, nothing happened to S. This is a good question. You should understand this question well, right? Because it's like there's a limited amount of tricks we can try to play, and we're definitely going to try to play some tricks on you with lists and like the deep copy, pointer copy stuff. That's a natural way of asking a question. So what was this? 2016 question 4. I encourage you to study question 4 from 2016. Explain in plain English the following mystery function. Remember, this means that we want the overall purpose of the code. Yes, not a line-by-line description. Yeah, so don't write line 1 creates a new list and it sets it equal to new L. Line 2 runs a for loop. Okay? What does it do? So this mystery takes in a list. It creates a new list. It runs through the list by index and inserts at position 0 list of I. This looks like to me that it's reversing the list. What does insert 0 do? Yeah, insert at position 0, list I. Yeah, so the new list, I'm inserting at the front of the list. Yeah, I think this is going to reverse the list. Anyone disagree or have the correct answer? Okay, you look while I type. I'm pretty sure this is reversing a list, right? Because like what's happening here is we're walking through the list that's been given to us, and we're putting that element in the front of a new list, and then moving and then putting it in the front, moving and then putting it in the front. So the effect of that should be that the list reversed. So mystery list. New L is this for I, and it's so weird to me. Like, oh yeah, these old tests never use in, which is like the whole point of Python. 1, 2, 3, 4. Okay, so here's my list. 1, 2, 3. And I claim that this is going to return the reverse list. Yeah. Yeah. So what you should write here is mystery function reverses the input list. Out of place, right? Not in place, right? It returns a new list, right? So that would be the perfect answer to this question, right? So don't over answer, right? This isn't biology. You just don't get to write down everything that you've remembered and hope for the best, right? Biologists know that this is what they do. They don't even deny it when I tease them for it. Maybe we should try and find the object meth one. You guys please practice objects, right? There is an expensive. There's a high value object question on the test, right? Dictionaries. Oh, invert grades. Okay, so this is like how you invert a dictionary. We've inverted a dictionary like 3 or 4 times in class. So remember, whenever you invert a dictionary, the thing that used to be your domain has to become a list, right? because like multiple keys make, there may be multiple keys that key to the same value. So that when you reverse it, you have a value that has to go to multiple keys. Right? So when you invert a dictionary, something has to become a list. Right? So I'm not going to do this one because we've done it a bunch of times. As efficiently as possible. No, where's the object question? Oh, here it is. Okay. And this is good because this is similar to like what we're going to give you on your test. So like some of the code, we don't trust you with blank spaces anymore. So what we're going to do is just have you like fill in the blanks for some of the pieces of code. Like we'll give you code that's mostly complete and it'll say something like fill in the 4 missing lines so that the code is going to do what it's supposed to do. And so you don't have to, in many instances, you're not going to have to code from scratch. Okay, so we have to complete the magic methods here. So finish the constructor in it below. Oh, they actually want us to write in the doc string? Okay, so this should be, can I write into here? This is going to be def underscore underscore init underscore underscore. It has to take in self. Right? Remember, every method in an object has to take self. Right? We'll definitely ding you for that. So it takes self, string, string, and float and returns none. And initializes, well, I probably should just write this properly. I'll get rid of that. So we have def, what is it, meal? Oh, sorry, class meal. We want to initialize this with self, string, string, float of what? Name, category, and cost. All right. Name, category, cost. Wait, cost should be float. Okay. So how do I set up these variables now? Like how do I set, is it like this? Yeah, there we go. So that's for that. And the string method, return a string representation of the meal formatted as follows. Name, meal name, category, meal category, cost, meal cost. Okay, name, category, cost. So we have def, which is a string. It takes itself. Doesn't take anything else. It returns a string, and it has to return the string that they want us to construct. Name, category, cost. Okay, name, category, cost. Formatter. Self.name, self.cost, self.category, self.cost. Okay? So just be sure to use all the selves in the right place. You will get dinged for not using self. It's like probably the most important thing in an object. Right? So self, 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 self. And remember that we have these other ones, like the add, subtract, stuff like that. You should know how to do that as well. This is easier. Oh, they have more for us. Okay. Complete the customer below. Initialize a new customer with a given customer ID. Okay, so that should be easy. We won't do it. Place the order. Takes a meal and returns none. Add the given meal to the dictionary of this customer's orders with the meal name as the key and the given meal object as the value. If I could type into here, it wouldn't be bad. Okay, hold on. Maybe I can. Right. Okay. Whoop. Can I type? Great. Can I fix the way that it's doing this? Left to right? Yeah? That's fine. Okay, whatever. So this should be what? This should be 1, 2, self. What? No. Rah. Init, self, The customer also keeps track of their orders in a dictionary named orders that starts as an empty dictionary. So we need to take an ID, which is an integer, table number, which is an integer, and orders, which is a dictionary. Yeah. Just going to try to change the color of this guy. Pink. All right. Now we need to set this up. This is going to be self dot, and it's basically everything. We just have to do like this. Self.id, self.table, number, this table, number, self.orders is a empty dictionary. Okay. So that should be the constructor.
Wouldn't you not have the orders parameter? This only take 2 integers.
That's true. Yeah. Okay. Place order. Add the given meal to the dictionary of this customer's order. Okay, so what do I need to take as input here? So we take, all right, so this is an object, so all we need to do is take the meal, which is a string. So how do we add this meal to their order? So it's something like, if meal is in self.orders, then we're great. Then we don't have to order it. What am I supposed to key the value to? With the meal name as the key and the given meal object as the value. Oh, we have a different, we're using this meal object. Okay, so this should take the meal object. Okay, so if meal is in self.orders, I really hope that we can key dictionaries by objects. I'm pretty sure we can. 2, 3, 4. Then I have to meal name is the key and the given meal object is the value. Okay, so if it's already in it, I don't do anything, right? Because it's there. So if meal not in self.orders, then self.orders at meal meal name as the key. Okay, meal dot, how do I get the name? String. Nope. Name, meal dot name. Okay, like that. Okay, that's what they want. And return none. So that one was more just about reading carefully, right, than answering. So yeah.
Should you be specifying like if it's in the order or not? Is it like it makes sense kind of, but it also orders something twice over, and the question doesn't say.
Don't invent new parameters. Just do exactly what they're telling you to do.
Should you be checking to see if it's in it? Only if it's not in it, or should you just always be adding the meal, the order? Because the question doesn't say to specify add it only if it's not in their order yet, and you can order something twice in your level. You can order like 2 large fries.
So I guess, well then it's just going to overwrite everything. Right, I can do this, I suppose. Yeah, that would work as well. But it's not a bad habit to get into, to like, before you key into a dictionary to see if it's there. But in this case, you're right, because we're just going to overwrite if it's there. Right? So like, yeah. So I can do it 5 times, but in this case, I'm just going to overwrite the key. So both is fine. Finish the code. Get cost. Return the total cost of this customer's orders. Okay, that one will be difficult. Because somehow you have to do something like, return the total cost. Okay, so this is going to take nothing. Oops, no one complained. Even I forget this. There should be a self here too. That's weird. How come they told us the name here but didn't put init here? That's inconsistent. So this should be init self ID, which is an integer, and a table number, which is an integer. Okay. This guy down here should take what? Just self, yeah? And I got to return the total cost of all the customer meals below. So, okay, that's my total cost. I'm going to accumulate into something called answer. I'm going to say for key in the self.meals. Is that what it was called? Orders. It was orders. Orders. So this is a meal name. 1, 2, 3, 4. Answer gets added. So now I need to look at self.orders meal name. Right, that returns the object of the meal. And then the meal object should have a cost attribute. Right? Cost, yeah. Meal dot cost. Return answer. Okay, yeah, that should do it. So it's kind of weird because like we have a meal object which we're placing as values in a dictionary, and we're keying that dictionary with the name, which is an attribute of that object. And so you should look through this one again, because again there is an object question on your exam. Any questions about that? All right, that's it for today. So last class on Wednesday. Please start studying for the final. Yay, final.